Okay, let's get started. Yeah, live on YouTube. Here's the meeting doc. Please sign in. Agenda. I want to discuss our conversation from this morning, which was signer/publisher. Phases. Anyway, so this morning we were discussing like these kind of binaries that platforms want to use, but they don't deal as much with the Buildpack API and what's a good place for them, and also where should they go, whether they should go in the platform API, whether they should be some separate extension spec. Hey, Steven.
Hey.
You were just
late. Yeah. Sorry, go ahead.
No, we were just starting, but the first item on the agenda was like this whole concept of binaries that just the platform uses, not as much Buildpacks, and where they should live, what should we do with them. And I think Juan also is working on his like a similar draft for something known as the publisher, which I believe can roughly be categorized under something pretty much the same, where like it doesn't interact with Buildpacks mostly. It's just something that like, or it can be at least designed to be a platform only concern, and Buildpacks don't have to care about it.
We need to make a lifecycle repo, meta lifecycle repo for everything that's not the lifecycle, but goes around the lifecycle, that manages the execution of the lifecycle and things around it.
I think the general question I had is, what exactly is the platform API? Is it the API for platforms and how they interact with the lifecycle to the Buildpacks, or it's just something that the platform has to conform to?
The API is maybe more, answering what the API is maybe more descriptive than prescriptive, but answering what the specification is intended to be, right, is, in the most narrow terms, is we're defining the Buildpack API is exactly what the lifecycle is going to do when it receives a Buildpack, and the platform API is exactly what the lifecycle, what the platform needs to do to the lifecycle in order to exercise its features. And so by extension, the Buildpack API is what does Buildpack author need to create in order to interface with the lifecycle specifically, and the platform API is what does the lifecycle author, right, need to implement in order to meet the interface that the platform expects. So these APIs have terrible names. One is really, it's really the lifecycle spec versus the Buildpack spec.
So the question I have is, where do these kind of things belong? Which are like, so we've talked about a couple of these things now. Like we have 3 examples of phases that can be reused by platforms that have got very little to do with the actual Buildpack API. We have the prepare phase, we have this signer phase, and we have potentially this publish phase, which will not be doing anything with the Buildpacks, but just the inputs that go into them and the outputs that come off. But they're not doing anything in the middle.
Can we talk through the different? Sorry, go ahead. I didn't mean to interrupt.
I mean, I was just going to say, which allows their compact matrix and surface area to be drastically smaller than than what the typical cycle phases expect, because like it's like the things the platform would do before calling the life cycle and things it will do after. So like there's very little here that needs to support all the different combinations. Um,
Can we talk through each of the things so there's like a better understanding of the different touch points? Like the cosine integration is something that, you know, takes some output of the build process, you know, in a format decided by the life cycle in the end, right? And uses that information to assign container images. What are some of the other examples?
so the published stuff, I've not quite read one's entire RFC yet, but in the last office hours, what we discussed was we don't entirely need to get rid of the daemon from the lifecycle. What we just need is a way to publish all of this extra information, like any any annotations on the manifest or the manifest itself that was supposed to be published, or these signatures or attestations at the end of this whole process, in a way that like it preserves all of this information. So the exporter can still export to the daemon. It can still load images dynamically from the daemon. The lifecycle will do as it is. It's just that any extra tidbits of information that we would need, we should be able to compute them during the export, because from our conversations with Jason and like GDCR folks in general, it looks like we can pre-calculate the digest that GDCR will actually push out.
Sure.
And with some certainty, we can, like, if we reuse the same thing, we'll get the same output. So when lifecycle is exporting things to the daemon, it can just calculate what the output digest would be if it were to push it out to the registry, store all of that information and the signatures on a volume, and then the pack publish step simply calls this publish binary that relocates that information and publishes the image that was supposed to be published to the registry.
And we'd store that metadata on disk in .pack
on
or something
volume.
like that. Yeah.
On volumes, yeah. Same way we store our current layers for caching.
So maybe have architectural opinions about some of that, but putting that aside, have you actually tried that digest reproducibility? Because there are a lot of things that can change, right? Like gzip compression algorithms can vary, right? Even like Docker's config blob versus its local config file, I'm not totally sure it preserves bit for bit.
So we asked about that. As long as we are publishing things through GGCR, the output should be reproducible. I don't know if Juan got a chance to like try out the disk. Okay, but according to Jason, those things are reproducible. The gzip compression is set by GGCR, and you can define exactly what you want it to be. Docker uses a different one, true, but you can.
But you're still gonna, if you're doing it entirely through GGCR, it means you're gonna put it in the daemon, and then when you push, you don't Docker push, you pull it back out of the daemon,
publish, yeah,
and then publish it. But then when you pull it back out of the daemon, you're gonna have to recompress everything, and why not just keep every, like why not load it into the daemon as a convenience for someone who's using the daemon, but then keep everything compressed already there in the volume.
You can do that as well. Like I'm not saying that like that's just, again, implementation details, but the idea was to just have the publish binary just store, like exporter when in daemon mode can store some of this information along with, again, that report toml with the digest, so that when it signed all of these things or created these annotations, the lifecycle knew this was supposed to be the output if it were to publish it to the registry, but it instead exported it to the daemon. And the publish will simply just take that, try to re-export things. If it doesn't match, it can just say like, whoops, something happened in the middle, and this is not what I was expecting, and these signatures and other things that you have are incorrect. You can still Docker push. That's you're not losing your app image. It's just that pack publish will have some safeguards in case something goes wrong or something has changed in the middle for whatever reason. But you will get the same output that you were supposed to if you were exporting things directly to the registry. Pack doesn't have to care about this whole thing again anymore, because like so far Pack is just like a lifecycle orchestrator. It just runs things and containers or imports logic from the lifecycle. It doesn't actually have to deal with all of this logic. So this way, like the publisher again is like a platform only concern. It's not dealing with the build packs API, but like we need some place to put it.
I see. So if this were in the life cycle, it would not be part of exporter because exporter runs after a build. It would be a separate thing adjacent to exporter that takes an image that was exported into the daemon, adds the additional metadata. That was exported to the daemon, regardless of where the bits are coming from in that case. Exports it and exports that to the registry. And is it important to version that? See, for that, I worry about not versioning that with the life cycle, because you're going to do things like reading layers in the cache format, or reading the metadata, the extra metadata that was generated during the build process, right? Like it feels important to version that along with the lifecycle binaries that are responsible for generating those artifacts.
I don't know that I agree.
Yeah, sorry, go ahead.
I was gonna say, I don't know that I agree that it has to be versioned with the lifecycle at all, right? I think that should be a contract in some form of specification on these are the file format inputs, these are the file format outputs, right? Like that's the whole purpose of the specification. So I think that's the bigger question that maybe, we should talk about.
But I think you need to expose a lot of implementation detail of the life cycle, right? In order for, in the case of, maybe not in the case of cosign with report toml, because that's defined in the spec, right? But in the case of this publisher thing, right? Now you have to expose the detail of where do you get where can I find the compressed layers on disk to export them? This is why I feel like we shouldn't, but sorry, go ahead.
That's again a platform concern, right? Like a platform is responsible for mounting volumes in appropriate places and passing data along the phases. The lifecycle in this case would just output these layers somewhere on disk. The responsibility of this binary is to just take whatever is on disk, use an appropriate compression algorithm that would ideally mimic what the exporter would send out. We can define that compression level and algorithm somewhere.
Sorry.
And then it just becomes a platform API concern. As long as the platform API remains the same, the output should be the same.
Isn't that file contract currently between one part of the lifecycle and another part of the lifecycle? The builder is running the thing to generate the directories, and then there's some step that turns that into a tarball on disk in the volume, and then the exporter reads that tarball on disk and uploads it to the registry. But that format of the cache, right, the compressed tarballs on disk, right, that's not part of the public API of the platform. That's an internal API between the different components. And now we're talking about interfacing with that externally in order to send those tarballs off to the registry. So to me, it does increase the surface area of the public API.
But I think like if you just consider that the exporter exports on disk in OCI layout or OCI format, and all the publisher is doing is just verifying a few things and publishing that OCI layout out, I think it's a very minimal API, and we're not exposing anything that's internal to the lifecycle. It's just saying, here's something on the disk, push it out. Just make sure that there are, like, just follow a few guarantees along, like the lifecycle produce these values, just check those values remain the same, and publish all of these different OCI artifacts out to the registry.
So we're standardizing on OCI. So if this implementation you're talking about exports to the daemon, but then also just keeps the entire image on disk in OCI format in addition to exporting to the daemon, right? And then publishes that on disk OCI image in OCI format. And so publish's job is a binary, you point it, it's like 50 lines of GGCR that has probably been written 1,000 times already, right? Take OCI format on disk and export to registry. In that case, it is no longer relevant to the API at all. It is a generic tool, and you would not necessarily want to version that generic tool with the platform API.
Except the additional checks. Like, we want to make sure that whatever digest that the lifecycle calculated for it, in order to compute, like in order to create the appropriate signatures, for example, or attestations, for example, remain valid. And in order for it to do that, it again has to take the report toml as input, or something that says, here were the output, like here were the output tags or something that was supposed to be published out. Like, let's say, like, here's the list of output tags that were supposed to be published out. Here is the calculated manifest digest. Like, we need those inputs to publish things out again, right? So when you did pack build -t whatever, it stored all of those images in the daemon with the appropriate tags. But now you want to do pack publish, and it should publish like all of those things out to the tags here.
Is this also going to take report toml specifically as its input?
Yep.
Yeah, and so like we have. Sorry.
But yeah, I mean, that's one suggestion. It doesn't have to, but that seems to be part of the platform API contract right now that's exposed to the platforms, and right now platforms use it for other things. I know KPAC uses it again for some other stuff, but that's part of the platform API right now.
Should we have a new repo that's just maybe Rebaser would move into this also? That's like this other set of tools, and then the API that other set of tools interacts with is not the platform API, it's the reporting API or something like that. I'm worried that we have too many APIs and specs and contracts already, and then we need to do less of that versioning, at least until we have version numbers that we can bump, at least until we're 1.0 and have version numbers that are more maintainable, right? But that seems like a good path forward to me. All right, it seems worth it in this case.
The other case was the preparer, which takes the same inputs as like the creator. That again was like a purely platform API concern. You're not doing anything with the buildback API. It's just taking the inputs that you would have given the lifecycle creator and modifying it.
The reason why I wanted to have this conversation is, I guess I see a slight differentiation, at least in what my goals are for the prepare phase, where the prepare operation is something that I kind of want to enforce that it occurs, whereas the publishing is more or less optional.
Why would you want to enforce prepare?
So if we take the prior example where you said that the platform spec is defining, it's defining that a platform is compliant. The reason why I would want the prepare operation to be in that document is for that compliance that says that you do these things, right? You call it prepare. Really what I'm trying to get at is I'm trying to, like, I just ran into this recently where going through Google Cloud Functions, when it builds your application, it doesn't take into consideration the project descriptor, right? So I'm trying to say that, hey, in order for a platform to be compliant with build packs and say that it supports build packs, that it accepts and verifies and utilizes the project descriptor. That's kind of more or less my goal. So I think that's the difference, right?
I'm
So
a bit worried about that because right now the project descriptor is an extension spec. And we've also talked about moving the project descriptor entirely out of our spec repository since it doesn't really have anything to do with build packs at this point. Like we have the build packs namespace, which has got everything to do with build packs, but the idea of a project descriptor itself doesn't really.
I think it's just the same as like the OCI layout, right? Is our spec leverages other specifications. And
Yep.
so you could say that our spec leverages the project descriptor specification, that's, elsewhere. That's, I guess, the way I envision that, and I don't see a problem with that. I think there is a bit of contention on us saying that, hey, in order for you to be a compliant platform, you have to recognize the project descriptor. Again, I'm kind of on that hill. I don't know if I'll die there, but if it's really painful to use the project descriptor or to use build packs across multiple platforms without the project descriptor. So I kind of want to enforce it, but yeah.
project descriptor aside, right? Just thinking about our architectural options. If this is a separate repo that's versioned separately, you could still say a builder includes the lifecycle components and the meta lifecycle components. And then the builder sets up, can be configured to always run whatever, right? Or like that separation doesn't, preclude us from having interactions between those components, right? You could have the creator execute meta lifecycle components if they're present, right? Or something like that. We shouldn't call it meta lifecycle.
Yep. We already made the mistake with meta build packs. Yeah, that was the idea, that these are components that have got nothing to do with the build packs API, but
Yeah, I'm trying to think through mine, and sorry if I'm being selfish, right? But if I were to say that the prepare operation is treated just like the publisher, right, where it's completely separated from the life cycle and not necessarily even part of the platform API, it just leverages the platform API in some way. I go back to my I guess the benefit is that there is tooling for platforms to say like, hey, now Google Cloud Functions, they like if I throw a bug and say like, hey, why isn't it recognizing my project descriptor? And I could point them to like, oh, you could do it very easily by using this, tool that the Build Packs project provides. That might be easier for them to implement it and then maybe just get on board. But maybe that's good enough, right? Like, and maybe we don't get stuck in this trying to enforce a prepare phase part.
Doesn't that mean that we are still keeping the project descriptor or the prepare phase option? It's just that now that we've provided it as a tool, platforms would be more likely to implement it because they see other platforms doing it and they don't have to like handle the maintenance burden of keep updating that each time we update the project descriptor.
Yeah.
It also makes release coordination from our side easier, like coordinating the project descriptor breaking changes across the different platforms was like a pain.
Yeah, I like this concentration of having strong input and output guarantees, and that's sort of what we're interacting with. Like I think exporter outputting either an image or an OCI layout. Those are very known outputs that a platform today can integrate with. And I think it's cool that we as a project could add something like a cosigner binary that does the signing and happens to read OCI layout. And someone could use that even outside of build packs if they really want. But obviously, it having the conveniences of reading like report TOML or something to get that information instead of you having to provide it would be a nice convenience. Yeah, I feel the same way kind of about prepare. I'm still kind of on the fence of that. Like I kind of wish it was just baked in the project completely, but it's sort of one of those things. It's hard to push forward. Like I just don't know that everyone's gonna want to do that.
Yeah, I think that's what I'm, bumping my head against is I could definitely see platforms saying, no, I'm not going to call a preparer, right? And then we really don't have a say in badging platforms to say, yep, they're 100% compliant, right? Maybe we need a certification or badging of sorts for that, but that's separate. Go ahead.
I mean, I think if we, to the point where we say we're going to make platforms run this thing because it's the way it should be done, those platforms will fork the code so it doesn't run the thing, right? Like we're building tools, we're not building a platform. I think I'm hesitant to say, if somebody, like, for example, I've been thinking about, what does it look like to run the Cloud Native Build Packs API on platforms like Cloud Foundry or Heroku as they are today, right? And that's something like, I think it's totally doable with a one-to-one mapping, right? If you just run the builder and the detector, but you don't run the exporter, right? And you could have a platform that is compatible with build packs, but can't do rebasing, or whatever. I think there's a lot of, and you'd implement the project descriptor in some very different way, right? Like the way you make a compliant platform would actually be hindered by the tooling being really restrictive. And the best thing we could do for platforms is to say, if you want to say Cloud Native Build Pack certified or something like that, then you got to meet these requirements if we really care about that kind of, consistency between applications. But the tooling we provide is flexible enough that you can integrate it however you need to integrate it in order to make your platform work.
So how do we envision this working? So like, let's say, okay, we get the preparer, we get the publisher, we get the cosigner, right? We all go into separate repos. One's a J Romero preparer, the other one's a Sam, which one are you cosigner and the other one's Juan publisher, right? Hypothetically, like there's no specification for any one of these components, right? These individual components are ultimately just saying, hey, we support platform API, 08,
yeah, exactly.
09 or whatever, right? And then you could use, like platforms could then choose to use those components based on their platform API, essentially.
Yep, I like that.
I might put them all in the same repo and produce one binary that does all these things instead of making people download like 5 different extra Go binaries, right? In order to
we can figure out the packaging problem separately. We can still keep them as separate repositories and import the main, like the entry point, and create one mega binary if we want to. That's a separate concern, but I think like it would also be easier from just a purely repository management point of view, like people who want to work on the prepare, just work on the prepare. People who want to contribute to the cosign or signing stuff can contribute to the co-signing stuff without having to worry about affecting prepare things. Or like, let's say Notary V2 comes along and we want to support Notary V2 signing. Now we don't have to worry about such deep integrations with a signing solution that we can't create a Notary signer in the future.
I worry about creating tested paths for platforms through the different components we're offering. So like if we end up with, the Build Packs project provides you 12 different tools for implementing the Buildpack API. And each of those tools has a separate version. And here's a giant Excel spreadsheet of all the compatibility between all of the different versions you can choose. Right? That feels less good to me than like maybe we say, okay, it's okay if pack, lifecycle, and other thing are separate. And yes, we have to manage the compatibility between those versions, but that's it, right? I'm a little hesitant to create something that's going to make platforms need to set up a ton of integration testing, right, against version constraints.
But here we will be testing against a specific platform API, right? Like why do these other tools care about each other? As long as you're conforming to a platform API, that's all we really need to care about.
Because if I was writing the cosigner one, like I don't actually care if it comes from the Buildpacks project. Like if it came from cosigner, like they could write this thing that we're talking about writing, like because there's nothing specific about a cloud native Buildpack. Like it's just a published image and they're going to sign it with a bunch of credentials mounted by the platform. Like it doesn't even need to be owned by Buildpacks. And like I like that ability that it doesn't really, I mean, it's cool that we'll publish one. Like it's great if we want to do that, but
that makes sense. I just, we should make sure that the experience we offer to platforms feels like, somebody has thought through their.
Yeah. And I feel like a lot of that is our outputs, like making sure that we're using like not made up outputs. Like I don't want to make up new files like report TOML. I'm already sort of like on. Like I know why it exists and I know why it has to exist for this. And like, so us making our own cosigner that reads that report TOML makes sense, but like minimizing those places and making it so that, because you could make a version of the signer that actually reads OCI layout and does the publish as well. Like it could publish the image and sign it all in one thing, and that would be maybe better from like a spec perspective. And yeah.
But I think we can figure out the repository organization, which is the idea.
I'm not a hell I'm going to die on. Go do whatever you want. Separate us. That sounds good.
No, I mean I don't really. It's more of a packaging and repository management problem. I'm more interested in just this specific idea around creating reusable platform API components. Like we have utility build packs. This is just the same, but instead of build packs, it's platform components.
Yeah. Platform concerns, being able to leverage.
So more like platform behaviors, if we want to call them like behavior APIs or something, right? So,
sounds like a good RFC.
We have 3 of them.
one mega RFC to rule them all.
Okay. That's helpful. I think that helps, and I think that'll hopefully alleviate some of the tension in the prepare stuff to move it forward.
So who's owning the extensions or behavior API stuff?
Is that a thing?
I mean, we have to write an RFC, right?
I mean, but do we though? Like,
do we? It's outside of
because an RFC to make export or do OCI layout is all that's required for someone to go create this. What is it, publisher, right? Like
I mean,
nothing else.
It was the same thing for the utility build pack stuff, right? We just needed like a list of things. Like we can't just go arbitrarily creating these things. We
and stuff. Yeah.
Yeah. Yeah. Well, I mean, you could do it under your own, and then like an RFC after it's all like done up to be like, hey, I would like to donate this to the project, right?
Yep.
And so you're not blocked by an RFC here.
Yep.
We have guidelines for contributing components now that we have a process for if you want to contribute.
You also get way less pushback if something is already working and easy to get hands on.
Yeah. I mean, this definitely opens the path forward, at least, to getting prototypes up. And I think this will also improve our RFC process in the sense that folks who are now interested in doing these things can have a proof of concept working without having to deal with lifecycle code or having to worry about like just this huge complex matrix. Like our RFCs, now that they'll have a proof of concept implementation, it would make it easier to accept them both potentially without like having to think about how it impacts the current project priorities. Like whenever we accept an RFC, we always have to think about like, shit, what other work is this going to supersede, or when will this even be implemented? This way we'll have an implementation out of the box, and it will be more about accepting it and putting some documentation.
One question just to be clear. So the only RFC we need is for specifying that the exporter should save the image, the output image. Also, no matter if it's pushing the image into the demo in a registry, also plus in the disk in OCI layout format.
Right,
And
a new option to do that, right? Yeah, a new option to flush to a particular path or something.
And also to do and calculate whatever it needs for the digest and put that information into the TOML file, the report TOML file. So that's actually what the RFC should do, and forget about the publish on whatever you want.
Then you can write a proof of concept around the publisher and then say, hey, this works. I would actually go about it like just first test if our theory actually works, like the digest or reproduce.
The digest stuff, yeah.
And like figure out what would be a good interface for this publish thing to accept as inputs, and then we can mold our lifecycle output RFC accordingly. So do we need any other information apart from report TOML in this case?
Exactly. If maybe we can generate something else, like can be more easy for others to create the same thing in some other way and then reuse this publish if they want, as JC was saying, right? Maybe the report TOML has a lot of information that it's not needed. It could be not needed for the publish tool to do its job. So maybe we can just export something else that we can define more easy, I don't know, in whatever other format, JSON or whatever you want. And
if GGCR can load from OCI, can you get the digest by loading the folder? Like, do we even need to output that?
I think there were also a couple other pieces of information we needed, like the tags we want to publish to. Like that's another thing that report TOML captures.
Yeah. Report TOML's fine for that sort of stuff, but I meant like, is there enough information in just OCI layout to do what you need in publisher? Because we talked about having more digest. Like, can you calculate that in publisher? Is OCI layout enough? Like, just to minimize?
We can. It was just about, so again, let's say it calculates the digest, but it's slightly, for whatever reason, different than what the lifecycle expected. And the signing binary use that to create the signatures. It's just
but it's the publisher. It's OCI layout is the spec, right? Like, I guess I don't see too much value in lifecycle calculating that digest and then writing it down, because if they're both working off the same OCI layout spec, then like they both will get the same answer, right?
Except the spec has a lot of variables. Like you can change the compression level. You can.
Okay.
It's essentially change the compression level, and that's pretty much it. Like that would be very specific to your implementation. Apart from that, everything else is
okay. Yeah, I just want to try to minimize any like like if you can calculate it with the data that we can get out in a format that we don't control, like because instead of report toml, like that's the way I lean all the time if we can, like if it's safe to do such.
If we output compressed layers, then yes, we don't even need to worry about report toml. But like,
okay,
I think we also discussed that we wanted uncompressed layers so that we could reuse it during a rebuild. But whatever, that's what. Sorry.
But I mean, if the exporter is doing the same thing in the daemon or in the registry, do we? It's going to use that thing that it's exporting to the. I mean, the OCI image that is exporting on disk. It's like what we are saying is exported, please put this thing in OCI format there for me, right? So it's not going to reuse anything in any other way, I think, right? Or am I wrong?
It's not going to be used in
I mean, we are saying that what the exporter needs to do is just save the image in OCI layout format on disk, right?
Yeah.
But it's still putting the image on the daemon on the registry in the same way that it's doing it right now.
Unless we have the publisher put it in the daemon too, right? But I guess we're talking about Lifecycle is going to put it in the daemon and also write OCI layout, right? Yeah, but if we did just OCI layout, then Lifecycle would need to know how you're going to compress in order to give you or actually, I guess the publisher would know everything because it's going to know what it's going to do the compression.
Yes, I at the beginning I thought exporter was not going to save in daemon or the registry. It was only going to save in OCI layout format, and then published was going to take care of putting the things in some other place. That was my first idea, but now I'm confused because what I understood was exporter is going to do the same thing that it's doing right now and saving the image in OCI layout format.
Or so what Natalie said around us saving the uncompressed layers on disk in launch cache, like we obviously don't want to repeat this whole thing. Like we don't want to put these uncompressed layers in the launch cache, also export to OCI layout format, also export to daemon. So like we also need to figure out a middle ground between all of these things. Like if we can reuse the OCI layout format in uncompressed format for the launch cache.
Okay, there is the necessity for reusing that information. Okay, because we can basically say that the launch cache is in OCI layout format, something like that, and we stop using the one we have right now.
Again, that I don't know the lifecycle details, so like Natalie will know better, but like that's what I assumed.
Okay.
Yeah, I wonder if the lifecycle could internally just start using the OCI layout structure, right? Because literally it's the same thing. It's just the directory structure for the blobs needs to be in a certain way, and then that OCI layout, compatible.
Yep.
And we have our own like cache format that is very similar, but is also not quite the same, I think. So.
Okay. Nice.
So I think the general idea makes sense. We just have to figure out like all of these connecting points for the final implementation.
Hey, let's build it and then let's get it.
Yep.
Okay.
I think the one thing, but one reason why I wanted to report toml as the common format was like, let's say you run the signer, takes in the report toml, and you say, like, I don't want to publish it right now. I just want to store it to disk. What would the signer output, for example? It could, again, just output report toml with the list of OCI artifacts and their tags and that need to go out, and the publisher could just take them in and put them in the registry. So that's why I wanted some common format for saying, like, here are the list of tags. Here are the corresponding OCI layouts on disk. Use this information to put the things in the registry.
Okay, so I'm not crazy. See, you're saying that then the exporter was not going to publish in the registry. It was going just to put it on disk, and then the publish is going to put that on the registry. Yeah. So okay. Yes, because I said okay. That's what I understood. Why it's a little different what I'm understanding right now. But okay, yeah. That the one idea was like that, right? The exporter just put things in the OCI format. That's it, and the published will take care of saving that in some other place. But if we do that, then it's not. It shouldn't be a different tool, right? Or it's more like it should be part of the life cycle.
So my idea was to only run the publish phase if the lifecycle was exporting to the daemon. If it's exporting to the registry, it can go as it is right now.
That is very strange, but I see where you're coming from.
Like if we want a user interface that is like pack build and pack publish or pack push, we need these two things. And if we need something that says pack build minus publish, and we want to optimize the output, then like the speed and performance, then we just need to publish it out to the registry.
So it's specifically a daemon publisher.
Yes.
That's interesting.
You should name it as such if that ends up being the case.
But the problem that we're trying to solve is essentially if the lifecycle exported to the daemon, how do we put those things on the registry, keeping all the information intact?
Sorry, go ahead.
With the registry use case, it's already solved. Like everything will be in its right place.
So could I make a maybe slight suggestion, and you know, please shoot me if this has already been discussed. But what if the exporter just supported, instead of daemon, it was like, you know, registry or OCI layout, right? And then it's really the publisher just takes OCI layout, which is essentially the same thing. It's just renaming daemon use case to OCI layout use case.
The issue with that was like going back to our previous office hours discussion. It's like, how do we handle dynamically loading things and reloading things and rebuilds and things being in the daemon and everything else?
Right. So you still have the exact same problems, right? It's just that you're specifying that the output would be OCI layout. So you're essentially saying my inputs could all be daemon, but my output is OCI layout.
Which gets also loaded to the daemon for convenience, yes.
I see what you're saying. I don't like it, but
so the life cycle still does what it does with daemon. It's just that the loss of information that happens with daemon is accounted for. That's it.
And we still haven't been able to convince you or have the implementation team not raised enough hell that we should get rid of the daemon support within the lifecycle?
I mean,
I still think we want to do that. That's still like a big.
And that's what I'm saying.
That's a goal we're doing.
If the team still wants to get away from the daemon, like why are we adding this bolt-on instead of a more like specific replacement?
I get that from a maintenance point, we want to get rid of code, but by getting rid of daemon and lifecycle, we're also pushing a bunch of responsibilities to the platform and making the whole process slower.
Okay, I will say this as well. It's already really painfully slow.
I was gonna say, I would actually question whether it ends up being slower. I don't know. I'm not sure it would get slower.
We need a better approach altogether. Like, do we need to solve it in a much better way than saying like, oh, the poor performance at this point in time is good enough, right? And have this a bolt-on approach because we don't want to go full, you know, external and then that be slow, or slower, most likely. And maybe we just have to rethink the daemon altogether.
We need the daemon for the inputs. Do we agree on that at least?
Yes, because if you're doing a builder, you might only have the builder only on the daemon, right?
Yep.
You built your own test builder. Yeah. So
But
we're going to have to push it into some fake registry, right? If you're going through like a pack hosting its own registry, it's going to have to slurp up or it could be a pass through of some sort to the Docker daemon, right?
So you don't need direct access to the daemon. You need a way to fetch from the daemon. Right. I guess my hang up is I really want to break the ties to say that you're actually interacting with the daemon. Like, I don't think that the life cycle and the specs specifically should have that constraint.
The spec, maybe not the life cycle, just purely from an implementation perspective, it makes sense for it to just load things from the daemon. Like when we last discussed this with the whole registry pass through, it was just way too complicated. And we were doing what the lifecycle currently does, but in a less efficient manner.
But if it's okay, I like Javier's idea. Okay, yes, I agree. We need to pull from the daemon. That's it. Okay, cool. We can pull from the daemon. But now what I understand is, okay, if we take the OCI format as the output, then something like the publish, like, that can be used from a platform to then put that thing into the daemon, it will be outside lifecycle. It's not a problem from the lifecycle if someone else took the thing and put it back into the daemon because that's what the users want, right? And it's a way to get off the daemon and put something else in the middle that it's going to take care of pushing that into the daemon, but it's not part of the lifecycle.
The point is, at the end of the day, you would still need the daemon flag in the exporter to read the run image if it exists on the daemon. It's just that you'll be reading things from it. You'll not be writing things to it. The interface for the lifecycle would be the exact same.
See, I don't know. I think if I were doing it, I would totally have the run images be like a local like proxy, like a pack hosted registry proxy.
But that we discussed the issues.
I know you hate it, Sam. I know you hate it.
No. So I think, like, just to give Jesse some context, we discussed this whole thing in our last office hours, and the reason why this was so complicated was because, like, one, we're thinking about it from a pack perspective, but not other platforms that rely on daemon, like the Spring Boot plugin, for example. So they would then have to figure out a way of concocting this fake registry pass through that the lifecycle can use, making their lives harder. And
but they can do it, right? Like, as it is, they're in a really old API.
Yeah,
so
they chose to make a platform. Like, there's going to be some work as we make breaking changes, right? Like, I know we don't have to make this breaking change, but I think we want to make this breaking change.
Even with this registry pass through, like, the final implementation was like, but the final implementation is literally what the lifecycle is currently doing. Calling Docker save, which puts the output in the Docker v1 format and then loading it in GDCR. That's what GDCR does. That's what your registry pass through will do. It's just moving it from one place to another.
Well, I think it's the same. I mean, to me, in my simple mind, it's the same thing that we're doing with cosigner, right? And publisher and prepare. It's like we're removing complexity from within the lifecycle and delegating that complexity to the people or the components that actually care about those things. So if a person or platform cares about the daemon support, then they should be the one somewhat responsible for it. Yeah, we could build a utility, to help them out. That's fine. But I don't know that it should be inside of the lifecycle. I think that's what we're trying to get rid of. I mean, another crazy idea is like, what if the lifecycle didn't even use registries at all, right? And it just did OCI layout stuff. But
That would just make
that's
things super slow, right? Like you can't use launch caches anymore. Like if you have launch equals 2 layers only, you just get rid of that entire optimization. I think like with the other things that we've talked about, there's no performance hit. With this, it's going to hurt like day-to-day app developers in how they use Pack and other things.
At the same time, like loading and unloading stuff from the Docker daemon is already painfully slow. And I actually think that if done right, if like the Pack registry had a volume where it kept all the stuff, then I actually think it could potentially be like basically a wash, like because it's going to be able to do some of the launch cache stuff that it can't do today, right? Like it's going to be able to check a registry and be able to skip exporting layers that we have to completely export today because you can't do that type of layer sharing when we like write the full image back, right? Like I actually think it'll perform better in some areas and worse in others.
How would the output layer sharing work for?
Well, I mean, I think Docker, like at least the exporter itself, will run faster because if it already had a previous build, like it'll actually be able to skip re-exporting some layers that are already in that registry, and then you'll still have to do the Docker save at the end of the day. But so yeah, I don't know. I guess it'd be maybe a little slower. I don't know. I'd have to. I wouldn't be surprised if it's
Because
pretty much the same.
The issue with introducing another cache is just inconsistency. Like now that fake registry has to ensure that take care of cache invalidation problems, which is like just yet another thing to worry about from a platform perspective. The other thing was so far platforms have never had to deal with any of this. Like
Hey, what if, right? And what if we didn't actually export to the daemon by default, right? And you just use pack build and it just like builds all your images and you do everything hunky-dory. You could then publish to the registry if you wanted to, and you never really touch the Docker CLI unless you really wanted to. Then you could do the pack publish to the daemon, right? So, and then you know that, hey, my poor experience is really because of the daemon and not so much the build process.
The publish is not even the issue, right? The issue is reusing and reading layers. Publish is the least of our concerns. Like we're not.
From a performance standpoint, it is the saving to the daemon that is the slowest bit.
Isn't it the reading? Like the saving part would cost the same, right? Regardless of whether or not we do it. Through the lifecycle or just have the lifecycle output something and then load it.
Yes, the inconsistency. There is an argument to be made. Yeah, like the complexity and lifecycle, it does stink, but because you're connecting directly to the Docker daemon, then the consistency from like an app developer's perspective is really good. If you understand how Docker works locally, right? Like, because like sometimes it's pulling images that you don't have when you do a pack build, but if it's there, then it's not. And like you have to understand how the pool policies and all that stuff work, which can be confusing, but it does allow you to use your like local Docker state of the world to like build stuff with. And anything we choose would either have to match that or be a complete breaking change, like Javier was saying, like just saying, be like, we don't really do local. Like you can load stuff into Pack, like here, Pack load this builder, like because you could go that way, right? Pack load builder, and you pull it from the daemon, put it into Pack's registry, and then use that when you do a build. But then those are very explicit operations that are like that are very obvious to the developer, though, right? Because sometimes you get today you do a Pack build on a builder. And if you didn't do pull policy none, it gets wiped out if you don't know what you're doing, right? You're like, oh man, that builder I just spent 10 minutes building is gone because like I forgot to do pull policy never. And like, so, I mean, I don't know. The explicitness could be argued as a feature there.
I would agree. And again, right now, just again, in my very recent experience, like I don't ever want to use the daemon, right? Like it just
Yeah.
to save an image is just so painfully slow for a standard image.
We're all saying this from perspective of a maintainer of the build packs project or a contributor who understands the project very well. I understand this from an app developer perspective who is just used to Docker, wants to run or build his images, and now he has to think about all of these different abstractions that we've created. Like as it is, the developer experience around build packs is like, especially the local dev experience is not that great as it should be. And now we are adding more hindrances. And no matter what we say, like local dev experience is I think it matters a lot. Like production use cases aside, like people who want to use build packs in production are already doing the right thing.
If we wait long enough, everyone will move off of Docker to something else anyway.
But that isn't happening, right?
I
Like
know.
we've seen
It's not yet.
alternatives pop up that still follow the whole daemon, and like we have Podman, we have BuildKit, but they still have a daemon. As much as we're trying to, like, we can kill Docker, sure, someday, but like at least the daemon idea, or
We just need a daemon wrapper that it's offers a faster interface for you to connect. So if we can solve that problem and offer a, I don't know, golden bullet to solve all your problems with the daemon, then we're done, right?
as much as we hate on daemon, like it's how almost any new app developer being introduced, like people who don't know about build packs, which is a huge chunk of container users, they are all so into the whole Docker world for local development purposes. They might be using Kubernetes for like production or something, but people still rely on Docker for local stuff.
Yeah, and I don't argue with that at all, right? It's just the workflow, I think, needs a little bit more focus because even as it stands today, it's a really poor experience from a performance standpoint. And so I guess I'm not seeing a lot of the downsides for things that might actually improve the sort of speed at which we could deliver additional features.
There's the performance standpoint, there's also the experience standpoint, right? Like right now, if I want to load stuff or like pull things or like reference build packs that are in my daemon or existing run image or an existing builder, I don't have to think twice about any of that.
I mean, you say that, but like I said, I've had many builder builds just wiped out, like by
My
pulling it
default
before.
pack pull policy is if not present.
But see, that's because you're experienced doing it. Like anyone who does it for the first time or hasn't done it in a while, you're just going to immediately wipe out the builder you just built if it's named the same as something else. Like if you're like extending another one and doing it, I don't know. I wouldn't say it's like I said, it needs work regardless the local experience, but I wouldn't say it's like super.
I mean, that also depends if you're dealing with public builders or not, right? Like if you're dealing with any of the any enterprise stuff, you're probably calling your local builder some like local builder or some random thing, which is a top level Docker namespace, which will probably never exist. So the daemon always errors out in your builder stays. It's only if you name your local version of the builder the same as the one that's published, you have those issues.
Yeah. I'll have to give it some more thought. I wonder if some explicit URL schemes could make like the front end seem still very approachable, but then we could like, use those as hints to do things through either proxies or through the daemon itself to, I don't know, like, yeah, I think moving faster in lifecycle is something we want. I think we want to drop that code because there's always like random folks who are like trying to use the daemon in like Kubernetes. They're like, oh, do I use like Docker and Docker? I'm like, oh my God, stop. Like, I don't want to think about that. I don't really want to support that long term. So like, I don't know, like having the baggage of being able to connect to a daemon, like we're gonna get like random, like, oh, this doesn't work in Podman's version of the Docker daemon when I'm running in Kubernetes. You're like, oh, that sounds so complicated. Like, I just want to make my life easier on the lifecycle side. So like, I want to push that to the platform. Like, it's your job to connect the daemon or whatever. If you want to use this reverse proxy registry thing, go for it. Yeah. Anyway, I gotta go.
Yeah.
See y'all.